the first thing we ought to do is introduce ourselves as OTN. So what I might do first, and oh my gosh, there's so many of you, I might just say names for OTN staffers and get them to introduce themselves and say what they do. So I'm John. I run the data shop at OTN. I've been working on nodes and the node concept for 7 years now. It's hard to contemplate. And so I'm really excited that you're all here with us. And so I will ask Angela to go next.
Hi, I'm Angela Dini. I'm the database manager at OTN. So yes, I mostly do the push and help with verification and the database structure. That's me.
Thank you, Angela. Naomi?
Hi, everybody. Naomi Tress. I'm the data acquisition coordinator. I liaise with researchers as well as other node managers, making sure that data is formatted correctly to come into the node, helping out when I can with node managers who have problems with our processing software, and making sure everyone stays on track for the various integrated pushes that we have.
Thank you, Naomi. Caitlin?
Hi guys, I'm Caitlin Bate. I'm the Field Operations and Data Acquisition Coordinator at OTN. So similar role as Naomi with data ingestion, teaching workshops and liaising with researchers. And I also get to participate and help with some field work.
Right on. Thank you. Brian?
I'm Brian Jones. I'm the developer for the Ocean Tracking Network. I develop tools and processes for loading data, maintaining software.
Thank you, Brian. Patrick?
Hello, my name is Patrick Martin. I'm the database analyst for OTN. So I do a lot of work with our push and verifying our data and making sure that what comes into the system is good stuff.
Very good. Very true. Ryan?
Hi, I'm Ryan Goss. I'm a senior programmer at OTN. I work on some analysis tools like the GLaDOS package and Resonate sister package. And I just do some general work with websites and also the notebooks.
Fantastic. Bruce?
Yeah, I'm Bruce. I also work at OTN. I'm a programmer. I write a lot of Python for the notebooks that we use to drag in data. And I also teach a lot of workshops.
Fantastic. Thank you, Bruce. That was the OTN data shop. I will probably forgo asking other OTN staffers who have joined us. Thank you so much for joining us, from having to introduce yourselves right now, but we will have a moment after the top of the show here if we want to chat more about who we are and what we do, and correct my often incorrect assumptions about who we are and what we do. But I did want to jump in. So you should be able to follow along using, hopefully I've got the right screen shared, the intro to nodes link that I've been posting in the chat. So we are talking today about what a node is, and then we're going to go right through to how it's built and the beginnings of how you might use it to aggregate and organize acoustic telemetry data, specifically to help a community of researchers pull their data together in the way that they are so keen to do often. So we partner with regional acoustic telemetry networks to enable detection matching across our communities. And so I do have a little PowerPoint here talking about how a node will benefit its users. And so I'm going to, if you're following along in the website, I'm going to change my share now, if I can. Hopefully this will work. How does that look?
Looks good.
All right. So it's my hope that at the end of this talk, you'll have a sense not only what a node is, but also what OTN's mandate is, what the benefits are of a node system as communities outgrow the more organic person-to-person sharing that is natural to do, the relationship between OTN and its participating nodes, as well as getting a realistic understanding of the work involved in hosting and maintaining a node. So about what the Ocean Tracking Network does, our mandate, our mission from our funders. We're a global infrastructure network funded by the Canadian Foundation for Innovation. We're headquartered here at Dalhousie University or in various bedrooms and living rooms in the environs of Dalhousie University in Halifax, Nova Scotia. We are funded as a major science initiative, which means we're meant to provide scientific infrastructure to our research partners. We've been operating since 2008, deploying ocean monitoring equipment in key locations around the world. More recently, we've done a little bit of oceanography and limnography by accident here and there. We use ROVs and gliders to get that done. We established partnerships with this global community of stakeholders to document the movement of aquatic animals in a changing ocean. The knowledge that is collected by OTN affiliated researchers has been useful to policymakers, industry, indigenous and coastal communities, and the general public. The way that OTN's data center fits in, the way that we as data managers help fulfill OTN's infrastructure mission and provide value to researchers and organizations that partner with us is by being a reliable and reproducible example of digital infrastructure. There are a couple of needs and concerns that researchers have that data managers are well positioned to help with. So when researchers are sharing data amongst themselves, combining their data holdings into a larger data set, the key is making sure that everyone is recording their metadata and data to a uniform standard. We at OTN have defined and refined a standard that meets as many of the needs of our partners and affiliate data networks as possible, while still being manageable for field work. We define, harvest, and publish high-level, project-level information in catalogs for easy discovery of complementary projects that might be already happening in your area. Generally, the more information collected and recorded about a project or study, the more likely that we can fill out metadata and search engine-friendly pages to help others discover that that project exists and to find data once it does get published, adding new value whenever investigators come along and find new applications for the results. For the last decade and more, we've been building and refining these metadata sheets that harvest all this necessary information at a project level as well, that lets us be confident that we can represent the project properly, both within our own data system and out into other more general data systems. This work is always ongoing. A recent example of an addition would be the tracking of map codes on instrument deployments. And it is important that we are always listening for new things that will need capturing and looking for ways to make this easier on people on the ground or on the deck, as it were. By having a well-defined set of metadata that can be understood both by humans and by computers, our partners will also find it easier to collaborate firsthand. And in telemetry research, you do derive so much benefit from sharing data with your near neighbors, but not excluding the world. Researchers, they'll want to compare notes and metadata, not just for the analysis of data, but to plan future deployments collaboratively, to understand how these programs rely on one another or on network maintained core lines to supplement their observing efforts. You can share methods and find each other to do those things, thanks to some of the standardization efforts that are going on. Now, it doesn't hurt that you can implement and share common telemetry data analysis standards since you're working from the same format of input metadata and data. And to maximize that benefit, we also partner with folks who are authoring analysis packages, and we help backstop these institutional or volunteer efforts wherever we find them, and that they're serving the community and filling in important parts of the data pipeline. So we make sure that our data is fit for their purposes, and we confirm that their packages can act on node structured data. So under the framework of the CFI funding that I mentioned earlier, we as an organization are meant to provide infrastructure support. And OTN DC, our data center, is the digital infrastructure support that guides information from the field book to the PostgreSQL database, to the detection report, to Zenodo, to OBIS. Organization-wide, we get this done in a few other tangible ways. We fund and maintain a set of core acoustic telemetry receiver lines around the world that researchers can leverage and rely on when designing their own studies. We loan out the receivers that we aren't able to use or maintain ourselves in order to supplement other studies happening in other parts of the world. We co-design and help innovate new ways to attach listening equipment to new platforms like the Slocum and Wave Gliders were in the past, and more recently to ocean physics drifters and ROVs. This helps lower engineering costs for new adopters and smooths the way for these new research projects to adopt those techniques in turn. Now, within the data shop, beyond just the metadata standards and software, we're also a human resource. The OTN-DC contribution to our infrastructure mandate for us also means being able to be a standby or a backstop to receive quality control and aggregate the data that's been reported to our databases. This can be from individual projects, from labs, institutes, citizen science programs, using any or all of the technologies above, performing the cross-network matching of quality control detections, and reporting back this most complete picture of that data to the researchers who deployed their tags. Those researchers can take that network-wide detection report, walk into the community-built software for analysis, and that is our contribution to the data pipeline. While it is a lot of fun to be there for anyone who would come through the door with data that they would like to register and reference, there are more than a few researchers that we would miss if we tried to be the sole arbiter of the world's telemetry data, for lack of time, for lack of trust, or for just not knowing about one another yet. So something that I have been convinced of over the course of this project over the years is that we're all very susceptible to Tobler's first law of geography. Researchers tend to be very interested in what's happening nearer to their study areas. And then depending on what their study animals are doing, perhaps they are progressively less interested in what's happening further away from it. They also tend to share views on what should happen to their data with their near neighbors. They are more trusting of their neighbors to safeguard their intellectual property. And they're likely to agree on how best to work together to cover more area and collaboratively coordinate their listening stations. And for more study species that are observed using acoustic telemetry, the global scale is not going to be the most important scale. So to be optimally relevant and useful to a global community of researchers, we at OTN have to empower more localized communities and collaborations. On the data management front, that means we empower the people who've been tasked by their networks to aggregate and disseminate data to enable you to guide your data through the quality control pipeline and aggregate it in exactly the same way that we do as OTN. This lightens the burden that's placed on you as regional data managers and aggregators, and lets the data that you receive be represented and trustable all the way up to the global picture. The reality is this kind of data aggregation isn't something you only do once you've already designed a database and coordinated data collection techniques with all your prospective colleagues. It starts more often as a shared network folder among a core group, a series of emails between researchers, as a promise that you'll scour each other's data after every season for each other's tag detections. These methods are a great sign that people trust each other, but they don't scale well at all. 3 researchers can easily keep in touch, but 10, 12, 20. Because the value of sharing detection data grows so much with the more people who agree to do it, it is often the case that the will to collaborate will scale you up much more quickly than the capacity of any one person to facilitate it. So this is where we can use nodes to make an impact. We can facilitate sharing among larger communities and guarantee a standard that can carry that contributor data all the way up to the global aggregate. And if all of our data sharing agreements are sufficiently aligned, this also provides global matching to data providers for participating nodes. So this is how and why we've come to support this strong regional organizing tendency, both at a policy level and with technology, keeping regional data management regimes empowered and in control of their constituencies' data where it's possible. To this end, we designed our database so that it's easy to maintain your own structure, certify and train the communities and operators who have adopted them into participating nodes, and we share and co-develop new additions to the structure and code that we all use to populate, quality control, and aggregate the data. We've maintained in-house versions of our database for regions since 2008 in the very beginning of OTN, first with OTN in the Northeast Pacific and with ATAP in South Africa. But we started sharing out the node software for independent operators as well recently. Well, I say recently, but 2015, 2016. And the FACT network was the first fully autonomous node that was stood up. Since then, we've sought to increase the autonomy and capacity of each regional node, hosting training sessions like this one to keep node managers up to date on the latest tools and techniques. We try and hold these training events once a year. Of course, global circumstances can and have intervened in recent years. One final thing worth mentioning is that investigators are very much like their study animals in that they do not respect borders. From a PI perspective, the intercompatibility of nodes means also that we can track membership in multiple networks and respect the policies that go along with each program's activities in each locality. This ends up being a much nicer arrangement for the PI than managing their own membership in multiple networks. They would report their data regionally to the closest collaborators, and the software will take care of ensuring that they benefit from the global network and that a single authoritative repository of their data is maintained in the place they're most likely to update and curate it regularly. So just to make clear how OTN's data policy affects the way that nodes share data, it's important to outline how we think about each type of data in turn. So at the entrance to the data pipeline, there's generally 3 big kinds of data plus project level metadata that we all need to process in order to produce animal presence information, and we'll deal with each of them over the course of this week. I look at this graphic, and the most interesting thing about it to me is that 2 out of the 3 pieces of information that fix any animal detection in space and time come from the humans that are recording them, often by hand. We've got receiver deployment history that gives us the location for a detected tag. We've got tagging activity that tells us what animal was carrying the tag with that code at that time. And then we've got the instrument itself that's recording times and tag codes and matching those 2 bits of information together to give us this animal at this time. The tagging metadata is the part of the system that most agree is the sensitive piece, and it is against each tag animal record that we can apply an embargo to easily manage the release of potentially sensitive information into the public sphere. OTN's embargo begins to tick down at the moment the tag batteries are estimated to have expired, and by default, they last 2 years. Researchers can waive that embargo at any time to speed up the publication of their data, or they can apply for an extension to their embargo to slow it down. Nodes are not bound to follow the details of this specific embargo and can design and implement their own rules for publication that will follow the tag information registered in their node as it collects detections from projects within their node or from other participating nodes. So at a high level, that's the game. By sharing a common set of processes that we can all run to quality control incoming data, and by having the exact same format in the OTN database as in each of the nodes, we can achieve this intercompatibility. The common quality assurance processes give us confidence that making comparisons and matches across these distinct data systems will still make sense. And the output formats are standardized between the nodes, meaning they'll be compatible with analysis packages that are designed to accept them. This helps us share analysis tools as well among all these researchers. The other major benefit about OTN having so many collaborators globally is that regions will discover new use cases and configurations, new problems and technologies that we will all have to become fluent in together. In building this capacity and connectivity between you who are coordinating and managing these regional databases, we also gain insight into emerging needs from all of these communities, and we're provided an opportunity to collaboratively tackle those challenges. This makes the extra overhead of open development of this data system and rigorous change management very worthwhile to OTN to be in the know sooner about new ideas and to get our system and in turn your systems caught up to speed with the help of data folks like you from around the world. So as a link in the chain between researchers collecting animal presence and movement data and the global understanding of marine biodiversity, OTN and our partner nodes have the ability to work together across regions and disciplines to securely and accurately move information towards decision makers and help researchers create change from local to global scales. All that said, of course I like nodes. I'm the guy who started building them. We've been working on these nodes for many years now, and I'm glad to say that Joy Young is here as well and has graciously agreed to share her experiences to give you a better sense of the node perspective from a community coordinator, node manager perspective, as someone who's running the largest independent data system currently in the OTN node network. And so Joy, if you are still awake, I will invite you to take over the share at any time.
All right. Okay, John, I can still see you. So can you just give me a thumbs up so you can see my screen?
Yeah, you're in control now, and we all see your screen.
Okay, wonderful. Thank you. Hello, everyone. My name is Dr. Joy Young, and I'm here because I guess I've been around the block a little bit, or at least the FACT network has been around the block a little bit. I'm going to tell you a little bit about the network and draw upon our experience as a network adopting a node, and talk a little bit about even my experience as a researcher from that side of things as well. So if you were not familiar with the FACT network, it was created in 2007. It's considered a regional collaboration of researchers. So it started in Florida. A couple of researchers got together and said, hey, if we share some information, we'd be able to really, kind of expand our study site. And from there, it just grew and grew and grew and grew. So our official mission statement is there on the slide. But essentially, we are a group of scientists. We are a community, and we also facilitate data exchange between our researchers. So why did we choose a node as a network? Our system was broken, unsustainable, maladapted. If I could put other bad words up there, I would too. For the increasing size of our network and the needs of our researchers. Like many other regional networks out there, we started with an Excel sheet. that was used to, it was just passed around via email, and people would put tag metadata on it. And then when a researcher would download, they would look at the sheet and find out who the researcher was and send them the information. And then we took a big step up and started using Dropbox with the Excel sheet. And so people could go and update their data a little bit more. But after so many years, Excel sheet was broken. A single individual researcher was sending 60 different files to 10 different researchers every single time that they downloaded. And it just wasn't a sustainable system. We were growing and we still are growing. So we needed a solution. And the OTN already had a working and proven system. In fact, we like to say a lot, don't reinvent the wheel, that we can work together and capitalize on the work of others so that we can all make progress. And the OTN already had a system. And I believe it was probably in 2016, John and I sitting down at a restaurant, kind of hashing this out and seeing if it could work for us. And John just kept saying, yes, we can do that. Yes, we can do that. I said, okay, well then let's try it. Now there were challenges when we decided to adopt a Node as our data management system. The first is new can be scary for people that are used to doing things an old way. If they're not understanding of why it needs to change. We needed to collect new types of data. So before we were only collecting tag metadata and then some contact information. Now we needed to collect VRLs, raw VRLs, deployment information, and project metadata. Getting buy-in, so getting participation, because the node is only as strong as the people that participate in it. So getting everyone on board. Logistics, where would the node sit? We are a regional group of researchers. We are not an institute of itself. So, where does it sit on the server? Who's actually going to push buttons? That type of thing. We would need to update our data policy because we had nothing about a node in there. So nothing about what would be produced as part of the node. So we would have to, revisit that. And then also the dedicated effort that it would take, that we knew it would take in order to process this data. So this would be a lot more information coming in that would need to be hand processed. So how did we overcome those challenges? And we did, and we are. The first, new can be scary. So we were very upfront. FACT has meetings twice a year. And during those first few meetings, we explained why things were broken, what was coming down the road. So it wasn't a big surprise. And then we had a short, like staggered time where people could bring in data. So sorry, let me clarify that. So we said, okay, our first push that we're going to do, our first deadline is we're going to have everyone just put in your 2017 data. That's it. That's all they had to put in. And so it kind of started with baby steps. And then we said, okay, the next push, why don't you go everything current and then add 1 year back and then add 1 year back. So people were able to grasp what was going on, but eventually get in their full data sets. Clear instructions. So we created a PDF that walks people through exactly what forms need to be filled out, where it goes, where they can process or where they can access their data. So very clear, written, that we can essentially hand it to anyone that understands how they can use the node. Buy-in is actually fairly easy. The benefits definitely outweigh the concern. John talked about some of the benefits. I'll touch on a few that researchers have expressed. But once people start using the node, it's like a snowball kind of going downhill. People put more of their data in there, and then as the network grows, new projects come along, they just start right into the node. So really buy-in happened pretty easily. The logistics side of things, we have strong partnerships with the Ocean Tracking Network, Socorro, which is our regional IUS, and the Animal Telemetry Network. So with those partnerships, we were able to house our node on Axiom Data Service or Axiom Data Science servers, which is the science company behind Socorro. So we have those strong partnerships that actually gave us the logistics in order to have a node. All right, updating a data policy. I don't know what to say other than you got to do it. It's just going to be part of this. As John mentioned, as he put it, sufficiently aligned data policies, which is important. We are a regional group for a reason. There's not just one, gigantic group. It's because regions differ in what their memberships, what their, comfortability levels are, what their priorities are. So that those things can differ between data policies. However, if the underlying elements are the same, that's what's important. Because as John said, one of the first things with nodes we had to hash out, it's like, well, okay, if we share between nodes, like which data policy does it fall under? So now we have a standard for that, yes, sorry, you got to look at your data policy or create one. But once you're done with it. Okay, and lastly, dedicated effort. In 2018, we were fortunate enough, we had a data manager, and that was me, funded by the ATN through Socorro. So we were able to have some dedicated time specifically to this. And we are growing our team. We have Dani and Beth here today. So we are growing into a full data team, not just one data manager. So I like to put these facts, these facts up there, just to little show off for the fact network. But really, I just want to show you how big the node has become in these few years. So we have over 2,000 stations registered, with almost 14,000 deployments. And I'll tell you, this is actually out of date with this new push that just happened. We have a database of almost 212 million detections, over 8,000 tagged animals, 108 species, and from that we can calculate that we have over $4.5 million of telemetry assets currently in the water right now. That type of information is not information we would have had without a node. And I know that might seem trivial and might seem this, but when you're writing a grant, when you're writing a report, when you are giving an interview, you can pull on some of these numbers and talk about this is the community and the network that you're contributing to. And that really helps people. One thing is to get funded. So now it got that big, and it takes a lot of effort for the information, for the data to come in and for our database to get that large. So I want to talk a little bit about connectivity. This is a big selling point for people in Node. So this is a map that, thank you, John, for putting together. Very quickly, it is just a map that shows deployment locations. And what I like to show this map and say that essentially that is your effective research space. Like that is anywhere your animal travels within that, you are going to get detections from that animal. So people are like, wow, that's great. It's a big selling point. So FACT not only increased in size due to the contribution of FACT members, and that there is a lot of research that goes on generally in the Southeast US, but also because there are more and more cross matches between other networks. So researchers are benefiting from this larger study area, like I just mentioned, that they can track these coastal pelagics quite far. They have quality controlled, I would say, to the equipment level of data. And that's very important. Once you start realizing that you've received data from 50 different sources and you don't know how it was treated, especially if it's just detections that were pulled out of a CV, it's like, well, were they time corrected? Did anything else happen? Did they open it in Excel and all the seconds dropped out of it? All of those issues. So having confidence in the data that you're receiving is a big benefit. That standard format makes life much easier for researchers because you can actually start your analysis. You don't have to start 2 weeks of formatting all your different files to bring them together in order to start your analysis. So it's a same standard format. And with that standard format, it's easily ingestible into tools like Latos or Resonate. And new tools that are coming out are being developed based on that format. So really, you can be really part of the game with what you're going to receive from the node. And there is no burden of finding tag and receiver owners. It is a thing of the past, and having to send and email data. And I like to tell this story. And it was with me, and I would send out information from our array out of Florida, and I had someone email me and say, a researcher say, hey, could you resend me all of my files? I lost them. which went back 4 or 5 years. That's not necessarily feasible to do. It wasn't feasible for an individual to do. With something like the node, you don't have to worry about that anymore. The data are always there for you to use. So all of that equals more time doing actual science, which is what we want, right? So we went to school for. I want to talk a little bit about that cross-matching we said about connections between FACT and the other networks. So I just pulled out some of the major networks here. So what you're looking at the left is my first attempt at a shell layout. But these are connections or matches that have been made within FACT and between FACT and other networks. So in 7 data events, and I realize we haven't talked about timeline yet, but essentially when we do data matching, it's done in a specific set of time, and it's all coordinated. So since 2017, since we came on, we've had 7 data events. Since then, we've had nearly 1,700 unique connections between 347 projects. That's a lot of connections. That's a lot of data that are able to be shared. Those are animals that have been tracked that we never knew where they would have gone. Without that, that is an immense amount of new collaboration that can happen in new projects. And in that includes 120 OTN, 48 FACT, and 6 Migramar projects, which we think is amazing. And again, those stats we would not understand how well connected we are to other areas without something like a node. So again, on the shell graph on the left, that's color coded with FACT being in yellow, OTN in blue, ACT in red, and Migramar in orange. But what I want you to take away from it is if you look, you can see that there are some darker lines, but if you keep looking back and back and back, there's lighter lines. There are just more and more connections that are happening in there. And we only expect that to increase. We also can do really cool stuff using a node. So we just launched this, so I talk about it a lot. We just launched this tool, and it's hosted on the FACT website, which is hosted by Socorro, and it's called the Davit. And so this is a tool that's meant for the public, general public, grandma, teachers, things that they can go on and they can look up distribution and range by species. So they do a click, they get a visualization. Now, how this ties to a node is the data are pulled from the extracts from the node. So we wouldn't be able to do something like this, like an automatic system. Researchers don't have to do anything extra in order to participate in it. They just have to opt in. We would not be able to do that aside from a node. We just wouldn't be able to collect that information, and we wouldn't be able to update it on a timely fashion. Now, why this is so important, because a very hot topic is about making telemetry data public, but also we like to push is how can we make it informative, and that's what we really want. Is we want the public and we want fisheries managers to understand the research that we're doing and to get that information out there. So like these tools like this are incredibly important for that effort, and they would not be possible without a node. So lastly, I'll say a node, you won't regret it. I feel like I should have pom-poms at this point. John may say he does say he's like a node nerd. I do like talking about nodes a lot too. For the first 2 years, this was me. I was talking about nodes, didn't really understand them. But today, if you are starting a node or if you've been working with a node, the last piece I will say is that understanding how these nodes work and working with the data really is going to give you a peek into this area of science. And I don't think you're ever the same kind of once you peek behind that curtain. So congratulations on being here. This is the first step. I said myself, Dani, and Beth are here from FACT. And if anyone has any questions that you would like to talk about experiences, we would be happy later on if people want to chat or any of that. So thank you very much.
Thank you so much, Joy. Can you click one more for me? I'm just going to use your share for the schedule. This is how we're going to spend our week. Thank you so much, Joy, for giving us the inside track on, in many ways, the first fully autonomous node, the no training wheels node, the the fastest growing thing. I think, you know, in many ways you've run out ahead and found some of the obstacles that these folks won't have to deal with now that you have found them. Yeah, we appreciate the work that you've put in to make us a better version of ourselves, all of us together. So yeah, super happy. You know, the trip down memory lane especially has got me all misty, so that's great. So here we are, we discussed the concept of a node. For the rest of the day, we're going to talk about things like the structure of a node, what its inputs and outputs are. We're going to spend some time making sure everyone's got their setup squared away. We'll talk about how the data loading workflow operates, what node managers do in order to the proper care and feeding of the OTN node data system. And if we're lucky, we'll get all the way through to project metadata on Monday today. Then we will spend the rest of the week going in turn through all the different types of input data, tagging, deployment metadatas, detections, and then the extra weird and wonderful stuff in supplementary notebooks. And then we'll talk about the concept of a data push, because all of our nodes have to coordinate a little bit in order to produce a shiny copy of the data that we think is fit for cross-referencing. That is called a data push. The orchestrator of the data push is joining us next to talk about the node structure and outputs. So the other things we might spend time on this week, we might have a chance to sit in on a study hall if we're ahead of time, which I'm almost sure won't happen. But if we are, on Thursday, we might get to meet some of the folks from the community who are going to sort of give us an idea of what tomorrow's problems are. We'll also talk about data policies, how to fix data errors that might creep into the database despite our best efforts, and talk about how you're going to be able to feed back into this system, create new processes that will become notebooks, and help us develop the next iteration of the data system. And then Friday, for those of you who have a live node, we will do tandem real-time data loading with hands available to be holding with the OTN data center staff. So that is how we're going to take up the rest of our week. So if you are here to do some of the work and get the work done, stick around with us through the rest of the day. Those of you who are not going to load data to a node, this could be an okay time to hit your next thing. But if you have questions, this is also a good time to throw them in the chat. We'll try to get one or two of them figured out. And yeah, with that, I think we're okay to turn right over to Angela. Actually, there's one more thing I might want to cover, which is it's on the website, but it's not in the presentations. So if you're following along at this link, which I will repost, it is still, despite the fact that it is much easier than the manual system, there is still a lot of work that goes into managing one of these systems. There are some tips and guidelines on how to be successful as a node manager. You have to make sure that there's time each week to put on that node manager hat and get into working with other people's data, which is a very altruistic exercise. And there's going to be a mountain of work off to the side that you're going to want to do instead. You have to be familiar because people are going to ask you. You're going to be the person who knows everything for your region. So the metadata reporting templates, knowing how they work and helping people follow the formats carefully will be a job that will get easier with time. You want to make sure that you're staying in touch with us at OTN. We do our best to be available. We are on Slack at ridiculous hours of the evening and morning. Please don't hesitate. So that you're able to align what you're doing and your detection matching, especially across all the other nodes. We have a version of the tools that you'll use to load data, and we'll make sure that that's staying up to date and getting new features added to it. So just making sure that you're keeping your data slicing knives sharp is important. And then to make sure that you're staying in touch with the local telemetry community. So know the kind of people that you should be reaching out to next, and we will help you meet those people and reach them if we can. And also just keeping an eye out, be willing to learn, but also to ask questions. So whenever we hire someone new in the OTN data shop, I always tell them, you have 6 months where we haven't figured out how much work you can handle yet, and you can just sort of see what's going on and decide a way that you might like to make it better. And so take advantage of that time and come up with an idea on how to improve the process before you're completely entangled in it. This is true for everyone. So as you're looking and as you're learning, there will be hopefully a moment or two where you'll realize that something could be better, and don't hesitate to bring that up, and we'll try to make it better together. Okay, I promise this time, Angela, I am going to throw it to you now. Thank you so much for listening in, and we are checking the chat. If you have questions, we'll talk about it in the chat together. So thanks so much.
I'll steal the screen share from you if that sounds good. Everyone see my screen?
We've got you, yeah?
Perfect. So yes, on to the data system. So the OTN data system is a set of interconnected nodes, as discussed earlier. Nodes all share an OTN style database structure, which can be used through migrations. So these databases are subdivided into schemas with types tracker, deployment, and data. So tracker handles the animal metadata, or shows a project that only uses the animal metadata. Deployment is the type of project that only deploys receivers, and data is both. So the other important schemas inside our database structure is the OBIS schema, which is higher level tables that all of the metadata is aggregated into. AirDAP, which serves data through an AirDAP data portal. GeoServer, which is data that can be used to create a geospatial data products that can be published to GeoServer. The vendor holds data that is specifications about the tags and receivers from manufacturers. And Discovery holds the summary data, which we can use on our website to publish or to show the project pages and points on our map and use for statistics. So they're summary data. So I'm going to minimize that. So this is our general layout, where we first get data acquisition or metadata coming in. It's then put into project schemas of these different types described before, where they are QC'd and processed into upper level tables, moorings, animals, etc., into the parent schema through the use of inheritance, which just means it automatically goes into the parent schema. This then, during these pushes, can be moved into the Discovery, GeoServer, and AirDAP schemas described before. Oops. So each data type that was described before, project, tag, deployment, and detections, has its own data path. Project metadata has its own unique one, so I'll describe that in a minute. But for each of the deployment, tag, and detections, they start off by the researchers filling them out and giving them to you node managers, and using a specified format that can be found on the OTN website. They then are, through the notebooks, are processed up to our raw tables inside the database, which are often shown by, we normally do a C underscore and then the name. So that's our raw tables. They're then further processed in the notebook to intermediary tables listed there in purple. And then further processed and verified and everything into the upper tables, moorings, OTN animals, and OTN detections, which are then put into the master schema, in this case OBIS, through inheritance, as described before. So for project metadata, it has a more unique one, as described, where it usually has a type of project determined, which can, as described before, the tracker, deployment, or data, which can determine which type of project tables are created. So the researchers will fill out this project metadata template shown on our website and can send it to the node managers, in which they look at the metadata and see any obvious errors, and then can run it through notebooks to process it and to create schemas for it and the different types of tables that can be used, as well as fill in project tables such as which contacts there are, what scientific names there are, etc. Then gets passed to OTN, where someone on the OTN side will verify it and make sure it all looks good in the database side. So we also can create data products, which can be used for scientific analysis. This was touched on earlier, but so every 4 months during the data push, we do cross database matching, in which we do within each node, we see the matches, and then between the different nodes, we can do matches of detections in animals. We also verify everything during this push or higher level verification, and can update the schemas described before, the Discovery, AirDAP, and GeoServer. We also can give a list of detection extracts to send out to researchers, which gives information about all the detection matches. These detection extract data products can also be used for the analysis packages, such as GLaTOS and Resonate, and they're specifically formatted for those. So the last thing I'll touch on is that it is very important to back up the database, since there's no undo button. And it can be, that can be very important. We recommend discussing backup strategies within your network. And generally, it's a good idea to back up daily with different copies in different physical locations. Yes, any questions?
I think this is a good time to pause for questions.